Today, we're going to continue our discussion on continuity, and we're going to give you some functions where you have to find where the discontinuity is, or if there is even a discontinuity. So looking at this first problem, okay, example 1, all right, find each point of discontinuity. Which of the discontinuities are removable? Give a reason for your answer, all right? So we want to say if this is continuous or not, okay? Y equals x plus 3. So this is like your y equals x plus 3. Well, that's a line. And we should recognize that that's just the equation of a line. And y equals x squared plus 3, that's the equation of a parabola, okay? And what do we know about a line? All lines are continuous. There's no breaks, all right? And x squared plus 3, that's a parabola. That's that U-shaped curve, right, from Math 2. What do we know about that? Well, there's no breaks in that one either, right? But this is a piecewise function, so where the break could happen is where it switches pieces. So for a problem like this, we know that that's a line, no breaks, parabola, no breaks, but where it switches, which in this case is x equals 0, we would need to determine whether it's continuous there or not. So if we look at this, we need to find f of 0. That's one of the first things, right? F of 0. And f of 0, okay, this tells us right here that when x is greater than or equal to 0, we need to use this one. So this would just be 0 squared plus 3. And then calculating that would just be 3. And then we need to also find the limit as x approaches 0 of f of x. But to do this limit, we need to look at the limit as x approaches 0 from the left of f of x. And we also need to do the limit as x approaches 0 from the right of, let's see, I was hoping I could just switch it and make that f of x, but I'm not. Okay, so f of x. And we want to see what this one equals, right? And if these two are the same, okay, and then this limit exists and we can figure it out, okay? So 0 from the left, that'd be x's that are smaller than 0, and so that's this piece. And so we could do a direct substitution in here, because 0 plus 3, so 0 plus 3, and that would give you 3. And then when x is approaching 0 from the right, those are values of x that are greater than or equal to 0. So we could plug 0 in here, 0 squared plus 3, and that's equal to 3. And so these two one-sided limits are both 3, which means the limit as x approaches 0 of f of x is equal to 3. And the function at x equals 0, the function is 3, and the limit is 3, all right? So we would say the limit as x approaches 0 of f of x is equal to f of 0, okay? So we would say here f of x, because it meets the 3 criteria, f of x is continuous at x equals 0. All right, so this function doesn't have any discontinuities. All right, let's go to the second one. For this next one, okay, x squared plus 4, that's a parabola, okay? X minus 4, that's a line. Individually, there's no problems. So where the problem can happen, is where it switches pieces. And in this case, where it switches pieces is at x equals 2. Okay, so we want to find f of 2. So what is f of 2? Well, we'd have to put it into this one, right? So that'd be 2 minus 4, which gives you negative 2. And then again, we have to do the limit as x approaches 2 of, and you know what I did? I'm so used to this. I wrote f of x and I should have written g of x. So I'm going to switch that. Okay, so the limit as x approaches 2 of g of x. And so to do this one, we have to look at the limit as x approaches 2 from the left of g of x. And if we approach 2 from the left, that'd be x's that are less than 2. So that'd be this one. And because this is 2, we can just do a direct substitution. So this would be 2 squared plus 4. And that would give you 8. And then we also need to do the limit as x approaches 2 from the right of g of x. All right. And then that would be From the right, that'd be this one. So we put in 2 minus 4. We could do a direct substitution. And it's because this is continuous that we can do the direct substitution, okay? And so 2 minus 4 is negative 2, okay? And those are different, so that means this limit does not exist. Okay, and so the function value is negative 2 at x equals 2. The limit doesn't exist at x equals 2. So we would say the limit as x approaches 2 of g of x does not equal g of 2. So it's not continuous at x equals 2, which means there's a discontinuity. Okay, so g of x has a discontinuity at x equals 2. Now, I would also like you to determine what type of discontinuity it is. All right. So I asked if it's removable or not, but what I want to know the type too. How can you tell the type of discontinuity? Well, this left-handed limit, right, as x approaches 2 from the left, is 8, and the right-hand limit is negative 2. Okay, so at x equals 2, it's from either side of 2. The y's are approaching 2 different values. If they're approaching 2 different values, that would be a jump discontinuity. So what g of x has here, and specifically, g of x has a jump discontinuity at x equals 2 because the limit as x approaches 2 from the left of g of x does not equal the limit as x approaches 2 from the right of g of x. So those two limits have to be the same, okay? And they're not, all right? Okay, and it's because these are 2 different values, okay? So here's h of x, okay? It's negative x squared plus 5 when x is greater than 0. It's x plus 5 when x is less than 0. So, okay, this is a parabola. There's no breaks in that. This is a line, no breaks in that. Where can it happen? It can happen where it switches pieces, which in this case is x equals 0. So we would want to find h of 0. Okay, so what do I use? Which piece do I use when x is 0? Well, this is telling me neither one. This is not defined when x is 0. It's defined when x is greater than 0. It's defined when x is less than 0. So that means that h of 0 does not exist. Okay, we could also say it's undefined. That's another way you could say it. All right, we still need to go through the rest of the process, okay? So we need to find the limit as, because we know there's, I should say this, we know there's a discontinuity now. We just don't know what type, so we need to go further. So the limit as x approaches 0 of h of x, we got to figure out what that equals. So to do that, I need to do the limit as x approaches 0 from the left of h of x. And to come from the left, that'd be less than 0. So that'd be this one. And we can put 0 in here and 0 plus 5. So 0 plus 5, and that would equal 5. And we take the limit as x approaches 0 from the right of h of x. And from the right, we'd use the top one. So that'd be negative times 0 squared plus 5, which would give you 5. Now, these are both 5, right? So that means this limit exists, and it is equal to 5. Okay, now we still know that the limit as x approaches 0 of h of x does not equal h of 0. So that tells us h of x has a discontinuity at x equals 0. So what we have here is h of x has a discontinuity x equals 0, like I said, okay? And because these limits, as you approach, okay, x equals 0 from either side, it's 5, but there's a hole there, okay? So when the limit exists, but the function value doesn't exist or it's a different value, okay, that tells me that h of x has a removable discontinuity at x equals 0 because the limit as x approaches 0 of h of x equals 5, but the limit as x approaches 0 of h of x does not equal h of 0. So it's because this limit exists, but the limit and the function are not equal to each other. That's a removable discontinuity when that happens. Okay, we have one more type of problem and then we'll be done. All right, so find a value k that makes the function continuous. So f of x is equal to 2x plus 3 when x is less than or equal to 2. It's k times x. I know it's kind of close together, okay? But k times x plus 1 when x is greater than 2. So 2x plus 3, that's a line, okay? Kx plus 1, that's also a line because k is just going to be some number, and some number times x plus 1 would be a line. So these are two lines coming together, right? And so these lines have to meet up. In other words, the two one-sided limits have to be the same. So as we approach x equals 2, because that's where it switches, as x approaches 2, that limit has to exist. And so we would have to have the limit as x approaches 2 from the left of f of x. That would have to equal the limit as x approaches 2 from the right of f of x. And we would have to know what f of 2 is. So we know f of 2 is equal to 2 times 2 squared, which would be 4, right? 2 times 2 plus 3. So that would be 7. All right. Now, for it to be continuous, both of these have to come out to be 7, okay? So when we put 2 in from the left, 2 in from the left would be this one. So that'd be 2 times 2 plus 3. And that would have to equal k times my x value of 2 plus 1. So this would be 4 plus 3, which is 7, is equal to 2k plus 1. And now I just need to solve it for k and I'll have it. So I'm going to subtract 1, and that would be 6 is equal to 2k. And then that would mean k would have to equal 3 for this to happen, okay? So if k is equal to 3, okay, then this would be 3 times 2, right, which is 6, plus 1, which is 7. So what we have is the limit as x approaches 2 of f of x. We already know that this one is 7, so the limit as x approaches 2 from the left of f of x is equal to 7, because that's what this is right here. The limit as x approaches 2 from the right of f of x would turn out to be my k value, which is 3, times the 2 plus 1, and that would equal 7, right? And so that means since these one-sided limits are both 7, this is equal to 7. And I should tell you this, we already found the k value, but I'm just showing you that this is true, okay? So we made these have to equal each other so that this one would exist, okay? So this one has to exist, and it turns out to be the same as the function value, all right? And so that means the limit as x approaches 2 of f of x would have to equal f of 2. And those are the conditions that have to be met in order to say something's continuous. So this k equals 3, it makes it work, right? Okay, and it's because those one-sided limits come together, okay? All right, you guys, that's it for today. Pretty easy lesson today, okay?